Here we're going to look at a trigonometric function 3 sine 2x minus 1 with a domain between 0 and 2 pi. Notice here how we don't have the closed brackets, we've got an open interval. And the question's asking for what values of p does the equation f of x equal p have 4 solutions. Now this p here is just any number, really, any constant number, and f of x is just the y value. So the y value is p, and we're considering the straight horizontal line here that's passing through this function, and we want it to pass through 4 times. So the best approach here would be to graph it. In order to graph it, what's happening at the y-axis? So the y-axis is dominated by the mean value of -1 in this case. It's also the amplitude of 3. So what happens is that we can easily find the minimum value by looking at the mean value and subtracting the amplitude. So the answer there is -4. And the maximum value, which is the mean value plus the amplitude, and that gives us a value of 2. We can set up the x-axis now by using the period. The period is dominated by the dilation factor from the y-axis. So here we can see it's dilated by a factor of 1/2. So the period is 2 pi, half of 2 pi, which becomes pi, and the scale for the x-axis is given by 1/4 of the period. So in our case, it's 1/4 of pi. The next thing to consider is the shape of this particular graph. So look at the shape. We have to identify key points. We've got a sine curve. So the sine curve has the 5 key points. The starting value is at the mean, the end is at the mean, halfway is at the mean value, 1/4 of the way is at the maximum, 3/4 of the way at the minimum, and that's how we join up the 5 key points. So now we're ready to actually sketch the graph. We start by identifying where the mean value is, and that's found at -1 right there. So we'll just lightly put in a there to indicate where the mean value is. Then we'll identify where all these, so that's at -1. The maximum went up to a value of 2 and the minimum went down to a value of -4. So that's -4 right there. So we fixed up the y-axis. Now we'll move on to the x-axis. Our domain finishes at 2 pi. So what we need to do is make sure that it goes all the way to 2 pi. One cycle is at pi and the scale is at pi and 4. So we go to the 8th notch there. So that's at 2 pi. And halfway will be at pi, right there. And then we can start to sketch our 5 key points. So we start at the mean value, finish up at the mean value, halfway is at the mean value, at the top. So 1/4 of the way goes to the top, 3/4 of the way at the bottom. So there's the one cycle for your sine curve, and then you repeat all that for the second cycle. Mean value at the end and at the middle, 1/4 of the way is at the maximum, 3/4 of the way at the minimum, and again there's the sine curve for the second cycle. Now you need to make sure that you identify that at the end points here with a domain that you have open intervals. So as you can see, I've drawn a curve here, and we've got the open intervals at the beginning and at the end, and I've labelled those endpoints as well. Now, once we have this curve, now we can consider these values of p. Now, f of x equals p is simply just a horizontal line. So if I line across where the y value is 3, as you can see, we have no solutions there. As soon as I move that horizontal line down to 2, you can see that we have a solution here and another one there. So we have two solutions where the value of p is 2. But we don't want two solutions, do we? We want 4 solutions. As soon as I move this a little bit under 2, you can see straight away again that we have 1, 2, 3, 4 solutions. And we have 4 solutions in many places. So if I were to continue from 2 all the way down, you can see we still have 4 solutions until I get to where p is -1. You'll notice here something interesting happening. So at the endpoints, they're open. So that isn't a solution. But we do have a solution here. That's 1, 2, 3 solutions, but not there. So we have only 3 solutions where p is -1. And so that would not be a value of p that we would choose. But we can choose any other value underneath -1 all the way up to -4. But at -4 again, we have those 2 solutions, 1, 2. So we've identified here that p can take any value between -4 and +2, excluding -1. So p belongs to -4 through to -1, this open interval, or between -1 to 2. Another way you could write this is to say that p is any value between -4 and 2, excluding -1.